scalar and vector quantities. So students, as we have seen that there are different types of physical quantities. We have seen that there are a number of physical quantities like you need a distance, speed, force, velocity, mass, area, volume, temperature. So a number of physical quantities are there. Now we will be classifying these physical quantities under two broad categories. So dividing all the physical quantities into two categories. These categories are scalar and the vector. So scalar physical quantities are the physical quantities which have only magnitude, or the quantities which require only magnitude for their description. They are called as scalar physical quantities. Whereas there are certain quantities which require direction also for their complete description. So such quantities are called as vector quantities. Okay. So scalar quantities, they do not have any impact of direction. So can you give any examples of the scalar quantities?
Time.
Yes.
The time.
Sign.
Time, sir.
Time. Okay. So time, the physical quantities. Okay. Okay. So the physical quantities which do not require any direction for their description are called as scalar quantities, and the quantities which require some direction, that means there is some effect of direction, they are called as vector quantities. Okay. So here for example we consider time. Time is a scalar quantity. Length, mass, distance, volume, density. Okay. So see, all these quantities, they are scalar quantities, they do not require any direction for their description. Then you have pressure. So pressure is also a scalar quantity. Then we have some vector quantities. Vector quantities are the quantities which have direction, which require some direction for their description. For example, can you give me some of the examples?
Sir, force.
Force, very good.
Displacement.
Displacement, yes,
Velocity.
and velocity. Okay. So the physical quantities which require direction for their description. And so that is why their impacts can be studied. We can understand them only with their magnitude as well as direction. They can be called as vector quantities. For example, force. We have another. We'll come to know about another quantity, momentum. So force, momentum, velocity, acceleration, and
Sir,
displacement. Yes,
sir, can retardation also come?
retardation is same as acceleration. So acceleration and retardation, they are same.
Okay, sir.
Just a different name is given. If it has some specialization, so a different name is given to that. That is what we call as the. Ah, so for just understanding a little bit about the vector quantity. So suppose you have a block and that block is being pushed by two people. Now the block can be pushed by two people in different ways. There are different ways of applying the force on the block. So I'll show you the two different ways what I'm talking of applying this force. So it can happen that some force is being applied on the block in the two opposite directions. The block is being pushed by some forces in two opposite directions. Here some force is being applied on the block and it is pushed like this. So this is one way. The other way is like the other way is like this. It can be pushed something like this. Okay. So see, these are the two ways by which we observe here that two forces are acting on a mass. So we observe here that two forces, they act on a mass, but the way they act is different. In the first case, we observe here that some force F is being applied on the mass from two directions. The amount of force acting on the two directions, if it is equal, so we observe that these two forces, they cancel each other. Here in this case, if the two forces, they are acting in the same direction, so these two forces which are acting in the same direction, they are not cancelling each other. So clearly from this description, we can understand that for certain physical quantities, it is necessary to describe their direction to understand their effect. To understand their fate, we need to describe their direction. Okay. So that is why we have the vector quantities. Similarly, they are added or subtracted. For example, in this case, the forces will get subtracted. In this case, the forces will get added. Okay. So similarly, if the force is acted along some other direction, it will produce a different effect. Now, depending on this, you have another concept, that is balanced and unbalanced. So about balanced and unbalanced forces, we will be discussing in our later classes, that what are balanced and unbalanced forces. Okay. So I think everyone is clear about the scalar and vector quantities.
Yes, sir.
Yes.
Yes. So now we move towards distance and displacements. So have we done distance and displacement earlier?
Yes, sir.
Okay. And who all are new with whom we have not done distance and displacement? Okay. So let's start with distance and displacement. Okay. So you have distance and displacement. How we define distance? We define distance as length of path, actual length of path traveled. So of path actual length of path traveled is called distance. And if you look displacement, so displacement is the shortest, the length of shortest path. of shortest path. The length of shortest path between initial and final positions. Okay, anyone having any doubt?
No, sir.
Okay. So the length of shortest path between initial and final positions along with directions. So along with direction, you have to provide the direction. So that makes your displacement. Now let us see the displacements and distance and describe them. As both of them, both the distance and displacement are length, so their SI unit will be meter. The SI, if you find out the SI unit of any of them, so SI unit will be meter. SI unit you will get meter for distance also and for displacement also. But in displacement, there will be direction. So when we say direction, so direction either can be represented at north, south, east, and west. When I tell you to talk of direction, so you will be talking of these directions: north, south, east, and west, right? You
If,
can also talk of, yes,
sir, if the displacement would be zero, then need to show the direction.
okay. Then you do not need to show direction, because if any vector has its magnitude 0, okay, so it can take up any arbitrary direction. So as per our requirement, it can take up any direction if its magnitude is 0. And this is not only for distance and displacement, any vector quantity. If its magnitude is 0, so it can take up any arbitrary direction. Direction specification is not important.
Okay, sir.
So, okay. So see, there are still other ways of specifying the directions. Like we can take the help of coordinate system to find out the direction. For example, if an object is in one dimension, so any one dimensional direction can be represented with two ways. So one dimensional direction can be represented with a plus or minus. So suppose considering this to be the origin, any measurements which can be made towards the right, they can be taken to be positive. The measurements made towards the left can be taken as negative. So with this, you will be able to specify the direction. So direction can be specified with the symbol plus or minus also. Okay. If it is in a plane, so if an object is in a plane, so it can be a two-dimensional. And then how to specify its direction. Okay. So this is a little bit, you can say, a higher concept to find out the direction in two dimensions. So suppose if an object lies over here, so to specify its direction, I can provide its direction with the help of angle. So I can say that the object is making an angle of 30° or 40° with the x-axis. So direction can also be specified with the help of angle. Okay. But this concept, specification of the vector or with the help of angle, is not for your class. Okay. So for your class, it's not there, but we can specify the directions more specifically or in a better way in with the help of angles. Right. So let us try to do a few questions based on distance and displacement. Then if time remains, we will try to do questions from speed and velocity also. So here, you see, a boy walks on a road 3 kilometers north and turns left. He again walks 3 kilometers and turns left. Now he turns left and walks 1 kilometer. So you have to find his distance and displacement. So you have to find his distance and displacement. Now to find his distance and displacement, first of all, we will since we are talking here for the direction is given in the beginning as north. So we will make our direction here. We will represent our directions with the north, south, east, west. So here we make our directions. Let's say you have the direction north, south, east, and west. Okay. So in this way, we will be moving on. So let us start from here. Let's start from the origin. And from here, we are moving initially 3 kilometers north. So from here, we move 3 kilometers north. From this point, now we turn. From this point, now we turn left. So if you turn left and move 3 kilometers, so you will move something like this and travel a distance of 3 kilometers. Okay. So you will be at this point after traveling a distance of 3 kilometers. So from this point, you again turn left and walk 1 kilometer. So from here, turning left will make you move down with a distance of 1 kilometer. So this is your final position. This is now your final position. Now you have to find out your total distance and displacement. So what is the total distance here? How much is the total distance traveled?
7 kilometers.
7 kilometers. Okay. And what is the total displacement? Yes. What is the total displacement? Yes. So his initial point, let us observe. So from the initial point to the final point, we have to find out the shortest path. And as we know that the shortest path is a straight line. So if you draw a straight line between these 2 points, you will get the shortest path. So this straight line should represent the displacement. Now let's mark all the points. Let this point be A, B, C, and D. So to find out this displacement, we need a proper some way to calculate this AD. And for that, if we draw a perpendicular, like this, so we draw a perpendicular, and hence Now we can use the Pythagoras theorem in the triangle. So we can use Pythagoras theorem in the triangle. See, so this distance base would be 3 kilometers. The height would be 2 kilometers as it has already traveled a distance of 1 kilometer. So the height of the triangle would be 2 kilometers. Base is 3 kilometers and we can find out the AD. Okay. So who will tell the answer? Yes. What is the answer to this question?
Root 13, sir.
Root
13.
13. So see, you will be finding out the total displacement which you will get as under root of 3 square plus 2 square. So 9 plus 4 makes it 13. Under root of 13 would be the total displacement represented by the symbol S. And in which direction is it located now? In which direction is it with respect to the initial position? What should be the direction? See, again, if you make the direction at this point, if you observe with the help of direction, so you get this one as the north, south, here you get west and east. So what direction should it be? You have north, south,
Northwest.
northwest. Okay. So this direction is northwest. You let root 13 meter northwest towards northwest. Okay. So this is the displacement. Okay. Let's do one more question and we'll try to find out the distance and displacement. Okay, see. Have Rani jogs around a circular track of radius 35 centimeter. Rani jogs around a circular track of radius 35 centimeter with a speed of 10 meter per second. So find the time taken by her to reach the opposite end. Also find its displacement.
Sir, is the radius 35 centimeter or 35 meter?
35 meter. Okay. I'm correcting, it is 35 meter. Radius is 35 meter. Okay. Okay. So find out. Rani jogs around a circular track of radius 35 meter with a speed of 10 meter per second. Find the time taken by her to reach the opposite end. Also find its displacement and hence average velocity for this journey. Okay. Anyone who has got the answer?
Sir, means we have to find the circumference, right?
See, the distance she has to travel is half the circumference.
Sir, so it will be 110 meter.
Plus,
Okay.
this is 110 meter and the displacement would be 1 minute, sir. 70, 70 meters, sir.
Okay. So you are getting here, but she travels a distance. I've got her distance as 110 meter. So I got her displacement also. You told the displacement also, and we
70
have
meter.
got 70 meter. Okay. Now, how much time is she taking? What is the time taken by her?
Sir, to cover the distance,
Yeah, to cover the distance. See? The question asks
11
Rani.
seconds.
Yeah, you have to find out the time, and the time it will be given by. You will use the formula of speed.
That cover
Yes.
distance or displacement.
How much?
Sir, that we have to find the time for she covering a distance or displacement, sir.
See, the question is pretty simple. Now you have to decide what one you have to use. Okay. Which one will give you the right answer that you need to describe. You need to think of. So see, she is moving in a circle, and suppose she started from here. She started from here, and
Sir,
now
would
she is at,
time taken would be 7 seconds.
okay. We are given with her speed. Okay. And the formula of speed is distance by time. Speed is distance by time. So time would be given by distance by speed. Okay. So distance she is traveling is 110 meter divided by speed, which is 10. So she will take 11 seconds.
Okay, sir.
Then what would be the value of her average velocity for this part of journey? Yes, what should be the value of average velocity? Okay, the formula of average velocity is total displacement by total time. So what is the total displacement is she making?
Sir, 10, sir. 10 meters.
How much?
Average velocity should be 10 meters mm, the towards west.
Okay, there is no east-west. Okay, here there is no east-west. We are not talking anywhere east-west. Have we talked anything in this question of
No,
east-west? No,
no,
so
sir.
we will not talk of that.
Then
So,
10 meters.
yeah, but average velocity is given by the formula total displacement by total time. So, we will find out average velocity. Here, total displacement is 70 meter. She has made a displacement of 70 meter. In how much time? So, she has made it in 11 seconds. So, 70 by 11, this is your average velocity. So, you will be getting here 6.3 meter per second. This is the average velocity.
Okay, sir.
Okay, so bye all of you. So currently I'm not feeling well. I'm having some headache. So we can end up the class. This is just 5 minutes before. And on Saturday you have your test. Do prepare for the test.
Sir, I had a doubt.
Yes.
Sir, how do we get 110 meters? I got confused.
Okay.
Sir, how do we arrive as the total distance as 110 meters?
See, it is half the circumference.
Okay, sir.
So find out the circumference divided by 2. The circumference would be given by 2 pi r.
Yes, sir.
So circumference is 2 pi r, and her distance, the distance that she traveled will be just equal to pi times of r. Pi is 22/7. Multiply with 35. So you get 110.
Okay, sir.
Okay. Any other doubt?
No, sir.
Okay, bye.
Thank you,
Bye
sir.
everyone.
Bye, sir.
Thank you, sir.